forces. If the resultant force is 0, then it is called as balanced forces. So by this time, object does not have no motion. Clear, everybody? That is what. See, if you want to make the object to move, you need balanced forces or unbalanced forces?
Unbalanced forces.
Unbalanced force.
Okay, that is what the things. Next, take one more example now. All of you observe. Hold one end of a string and from the free end and suspend a pan with some weights. So, for example, you are having a spring. Okay, so hold with your hand, holding the spring. Okay, Nivedan. So you are having a spring, and one end you just hold it, and another end you just hang some weight. Hang some weight. Clear, everybody? Please respond, all of you.
Sir.
So what
Yes,
I have
sir.
done? I have taken a string. I have taken a what? String. S-T-R-I-N-G. String, we will say, because I will introduce a new word now. That is why you have to be waiting for that. String. And from one free end, you have to suspend a pan. Okay, pan means therima, weighing pan, like this. Beam balance pan therima. Yes, like that. So suspend a pan and with some weight. So I am putting some weight here. So that is what W. What is the weight of the load, everybody?
W.
W. Now here two forces are acting. Can you tell me the forces acting on the string are? What is the forces acting on the string? That is what my question. Forces acting.
Muscular force.
Muscular force. String you are only holding, Nivedan, or else you can attach to the rigid surface also. Nothing wrong in that. Clear? Forces acting on it. I want it. Forces acting on string. S-T-R-I-N-G. I want it. So first thing, one force is acting downwards. The string is touching downward direction. What is that actually?
Gravity.
Gravitational force.
Gravitational
That is what? The force due to gravity. What is that?
Force due to gravity.
Force due to gravity, which is actually will represent with a W. So that is what W. So the force due to gravity, W is equals to what? M into G. Am I right or wrong? All of you? Yes? Nobody is responding. So the force due to gravity, W. Here we are not finding see that forces acting on the string. The string we have to find it. So one force is acting downward direction because of weight. That is what due to gravity, W. So it is always acting downwards or upwards? Fastly, everybody.
Downwards, sir.
downwards.
Acting downwards. Now, if this due to the gravity, the force is exerting downwards means, then this weight is also exert some upward force on the string. That force we is to called as, observe very carefully, the force exerted by the hand, as Mr. Nivedan said, Mr. I am holding the hand, I am holding the string from the other side, or I attach it to the some rigid body. So the string is also exert, or my hand is exerting force on the string. That force we is to call. You are pulling upward direction or downward direction. Check it. Suppose you are hanging something. You are pulling upward direction or downward direction. Yes, please. You are handing upward direction or downward direction. That is what my question. Everybody. Suppose I ask you to hang the weight. You are exerting. You are trying to hold upward direction or downward direction. Everyone.
Upward direction.
So force exerted by my hand or any rigid surface, whatever it is. Force exerted due to gravity, W, downward direction. Force exerted by my hand to hold the string is acting what direction? Everybody. It is
Upward direction.
upward direction. That force only we is to called as Mr. Lingesh said, what we is to call? Tension. What is to call? Tension. Force exerted by whom? All of you. Force exerted by hand. Exerted by hand is T. So, acting upward direction or downward direction? All of you. Acting. Please respond. Acting. Upward or downward?
Upward direction.
Yeah, upward through the string. Okay. So, through the string we used to say. So now the same thing represented in a FBD. What do you mean by FBD? Everybody. Free body
Sir,
diagram.
one doubt,
Free
sir.
body diagram.
Yes.
Sir, then in the previous example, we can say the table is attaining the tension.
No, table does not have, only string will be having the tension. That is why the table, the force exerted by the table on the book, we are considering as a normal, N. Clear?
Yes, sir.
Now here is a string. String means it is a tension. Clear?
Yes, sir.
Abrami, nothing, Abrami. You are holding the string. One side you are attaching the weight, and one side you are holding with your hand. So when you are holding the hand, definitely you are trying to hold the, as no, if you attach the weight will try to go down. But if with your hand you try to pull up, am I right or wrong? The string. The force which you are exerting on the string to hold upward is called as tension. That is actually a force. Clear? And the force which is acting downwards due to gravity is actually the weight. That is what W. So if I draw the free body diagram, anybody can tell me what is the forces acting on this? One force is acting upward direction. That is called as what? Tension along the string. And one force is acting downward direction. That is what? Due to the gravity. That is what is to call? Weight. Understand all of you? Please respond. Clear? So
Yes, sir.
if you add it more and more, for example, add weights continuously to the pan. W increasing. W is increasing. Weight.
Tension also increases.
Yes. The weight is continuously increasing to the pan. Almost the string will get cut. String will get cuts. Means in the sense of what? String will get cuts. Do you remember? The string will break. For example, let me like a scissor. I will use a scissor to cut this. So I'm having a scissor now. So until you have to keep on add the weights. Have you heard it? A procliner and all. Sometimes the belt will break and people will die and all when they're carrying the load. Procliner. Have you heard? Procliner.
Yes, sir, due to heavy weight. Due to heavy weight.
Yes, sir.
So actually they will tie the heavy loads. If they will tie the more bigger loads, more than the strength of this belt or string, then what will
Sir, so
happen?
that only in elevators also they are keeping
Yes,
this much.
Mari. Yes. Elevators also have a, remember, inside elevator, it is attached to the string. They will say 600 kg, only 13 people, only 15 people, like that capacity they'll put. Have you remember that?
Yes, sir.
This is the reason. Clear? So if you are keep on adding the weight, weight increasing, what will happen? Keep on add weight until if you notice that the string is going to break. Do you understand, everybody? So it is seen that when the downward forces keep on greater than upward force, then what will happen? The string will get cut and the pan along with the weights all will fall down. Am I right or wrong, everybody? The string will get down and along with the pan, all the weights will fall down. Am I right or wrong, guys? All of you?
Yes, sir.
Yes, please. So the same phenomena will happen in our lift case also. So the body moves if the resultant external force acting on the body is not equals to 0. Now why the body is moving downwards? Because W is not equals to T. Do you understanding, all of you? If weight is equals to T, the body will never move any direction. Understand, all of you? Puriyama Puriyada? Please respond. Now weight is keep on increasing more than a tension. So at certain point, the string will cut. Once the string will cut, what will happen? Entire weights, because by the
weight
time,
is applied
yeah,
on the
what is the resultant force? What is the resultant force? Resultant force is 0 or not 0? Resultant
not a zero.
not 0.
Not 0.
So that the body, it is not equals to 0. The resultant force is not equals to 0. So that the body will move in a particular direction. Am I right or wrong, everybody? All of you? Yes.
Yes, sir.
Yes, the resultant force is not equals to 0. So if you notice it, if two or more external forces are acting on a body, is cause the body to move. Okay? But they are referred to as unbalanced forces. So which the body makes to move, everybody? Unbalanced forces or balanced forces?
Unbalanced.
Unbalanced
force.
forces. That
Unbalanced
is what we
force.
should understand. Clear, everybody? Sir, both the pulling the rope in the opposite direction can be the example of tension. Yes, Abhirami. For example, all of you observe very carefully. So there is a tug of war. Ellame theriyuma tug of war. Mr. Sanjay.
Yes, sir.
Yeah. Tug of war, if you see, both are applying the same force. Suppose in the side rendu people irukka, in the side rendu people irukka. So both are applying the 100 Newton force like this direction, sorry, backward direction. And they are also applying the 100 Newton force backward direction. Both are opposite reaction. So both are equal forces. So 100 Newton is equals to 100 Newton. So what is the movement of the rope? No movement. Am I right or wrong? All of you understand? Clear?
Yes, sir.
Yes. So, for example, this force is increased to 200. So then total force here become what? 300 Newtons. So these people will fall forward direction and the rope also will come this direction. Am I right or wrong? Because this side greater the forces. All of you understand? Everybody?
Yes, sir.
Yeah, that is what. So while opening the container in kitchen, while removing the cap, does tensional force is exerted? No, Mr. Lingesh, string, wherever string. For example, lift. All of you observe lift. If suppose this is the lift is attached with the wires. Have you all noticed it? Pulleys and wires is there. Pulley and wire. Yes or no? Yes?
Yes, sir.
So there is a limit. For example, the capacity of the lift is 600 kg. So if the 600 kg means what is the weight? 600 into 10, which is equals to how much is the weight? 6,000 Newtons. Understanding, everybody? Understand? So means the tension in the string also maximum how much? The tension also string also maximum 6,000 Newtons. Clear? Understanding, for example, by the time the lift will never move. Do you understand, everybody? Sometimes you might be watch some videos. Lift is not moving. Overload, please go out. Overload, please reduce the weight. Like that they'll say. Have you heard the sounds? All of you? Heavy loads. So when the tension in the string and weight of the lift both will become equal, you cannot see the lift cannot move because it knows. Clear? So as soon as the weight is reduces, the lift will start moving upward direction. Or some lift, suppose there is no proper technology. Nowadays, advanced technology, lift won't move forward unless the weight is less than its tension. Suppose some lifts, if it is started moving upward, but the weight is greater than the tension. So what will happen? If it is little bit variation, no problem. If weight is greater than tension, what will happen? The string will break.
Breaks.
Maybe it is made with a metal, doesn't matter. If the weight is greater than the tension in the string will cut. So that entire lift will fall down. Am I right or wrong? All of you. Many accidents we can see that. This is the phenomena is happening. Okay. Yeah, swing in the playground. Yes, Mr. Lingesh. So everything is same. So this is what about the unbalanced force, external force. Unbalanced external force. Then with this we'll stop it. I hope you all understand. Now new things we find it. Tension. String. If you are getting a string or rope or whatever it is, you have to use a word called as not force. What is the word you have to use instead of force? All of you?
Tension.
Tension.
Okay. That is what.
Tension.
So please learn till here. And then from here, we'll continue in the tomorrow's class. Tomorrow we are going to study Newton's laws of motion. That is what? Observation of Galileo's. So before Newton is describing the motion, there is an experiment called as Galileo's experiment. So that experiment we people will discuss in our tomorrow's class. So after that, we'll move into the Newton's first law of motion. So, okay. So this is what about it. Anybody having any doubt, you can ask me, and also you can leave from the meeting. Thank you, everybody. We'll meet in.
Thank you,
Thank you,
sir.
sir. Thank you, sir.
Thank you, sir.
Understand, everyone?
Thank you,
Yes?
sir.
Yeah. Thank you.